In Chapter 3, we talk about different ways to measure data, and we'll look at variation in data in Lesson 3.3. So one of the things that we can look at to describe how the data varies is we can find the range of the data, or the standard deviation, or the variance. And we'll learn about all three of these measures in Lesson 3.3. One situation that is a good way to describe variation is found in the front of your Lesson 3.3 in the textbook, and it talks about bank waiting times. And in this situation, at the first bank, a manager controls the waiting times by the customers by changing the number of tellers as needed. At another bank, customers wait in a single line that feeds to the available tellers. And then in the third bank, customers wait in separate lines for each of the different tellers. And what they did is they recorded the wait times by the three customers. In Bank 1, all three customers waited 6 minutes exactly because the manager carefully controlled the wait times. In the second bank, with a single waiting line, the measures did vary. They weren't all identical. And so in this case, you can see that one waited 4 minutes and the other two waited 7 minutes. The third bank that has the multiple lines had a lot of variation. One customer just waited 1 minute, another 3, and another 14. What's interesting about this data is that if you take each of the bank situations and you find the average wait time by the customers, each of the averages is just going to be 6 minutes. And so remember that to find the average, you add up the numbers and divide by the total. And it just so happens that in each of the situations, the average. Here's another way to look at the variation of wait times, and we can do that by graphing the wait times. And so here's Bank 1. We've graphed the three different customers' wait times. All of them was at 6 minutes. And we can see that the mean is also at 6, and there's no variation at all from the mean, since all three customers' wait times are equal to the mean. In Bank 2, if we graph each of the three customers' wait times, and then we look at the mean, which was at 6, we can see that there is small variation from the mean, going below the mean or above the mean. And in the third bank, there's large variation from the mean when we graph all three customer wait times. One way to look at how the data varies is to find how far apart the spread is, and so we call this the range of the data. To find the range, you subtract the highest value in the data and subtract the lowest value from that. So it's the maximum minus the minimum. This is the type of question that you'll be asked to do on the test. Another way to look at how data varies is to find the standard deviation of the sample. Now your textbook does have formulas on page 101, however we're not going to use those formulas on the test. Those formulas are very time consuming and tedious, as you can see if you try to work them out when you do your homework. You should have a calculator to use for this course, and I'm going to explain calculator tips that will allow you to calculate the standard deviation of the sample just by entering the data in the calculator. Standard deviation of a sample is denoted as a little lowercase s, and if the standard deviation is equal to 0, then that means that all of the data are equal to the mean, or all of the data are the same number. This is the calculator that that was recommended that you purchase for the course, and so these calculator tips that follow are going to correlate to this calculator, and if you've purchased a different calculator and need help, you can either look at the instruction manual that came with your calculator, or you can Google the calculator model, and that will bring up the instruction manual for you. I've been very successful with getting calculator tips just by Googling that. But here are the calculator tips for finding standard deviation from the Texas Instruments 30x2s calculator. And so the first thing that you want to do, especially if you're doing homework, you want to clear any data that's been entered in from previous problems. And so the first tip is to press the second data button and then use your right arrow and underline clear data. Once you've underlined the word clear data, press enter. This will take you back to your home screen, and so now you are ready to make sure that you are in the correct stat mode. So the picture of the calculator that you see on this slide, if you look at the home screen, you'll see that in little letters it says RAD, which is called radians. Well, in our course we want it to say STAT, or stat mode. So this calculator in the picture is not in stat mode since it doesn't have that word on the screen. So to get your calculator in stat mode, you press the second data key again, arrow to the right until you've underlined one var stats, that means one variable statistics. Press enter and it takes you back to the home screen again, but this time you will be in stat mode. Now for this course, especially after Chapter 3, your calculator may just stay in stat mode since you won't really have a reason to turn that off. So this particular step that I'm going over right now is not something that you have to do every single time. It's just necessary to set it up in stat mode when you're ready to enter your data. So now we're ready to enter our numbers. So to do that, just press data. And it will come up and it will ask for x1. And so type in the first value. Don't press equals. You want to press the down arrow key. Now what you'll see next is it will say F, or frequency. And so you have the option, if you have a number that repeats a lot of times in the data, if you don't want to type that number repeatedly, you can count the number of times the data repeats and tell the calculator what that frequency is. So you can enter the frequency of that number, or the default that the calculator sets up is it puts it at a frequency of 1. So if you don't want to enter a frequency other than 1, then just skip over that and press the down arrow key until you get to the option for x2. So at x2, enter the second value in the data set, and then you're going to arrow past frequency 2, or frequency, get down to x3, then go down to x4, and so on until you've finished entering all the data. When you've finished entering the data, press the stat var key, that's our calculate button, and you'll have lots of different options that come up. You'll see n first, and n is the number of values that you typed in. And then if you keep typing the right arrow, you can scroll through different answers that the calculator did different calculations for. Now, it will give you X bar. So if you scroll through the list of options, when you see X bar, that's the mean of the data, or the average. And then you want to keep going for standard deviation. You want the one that says SX. SX is the standard deviation of the sample. So this is a much simpler approach to using technology to calculate the standard deviation instead of doing the formula in the book by hand. The standard deviation of a population is something that we really don't calculate often because it is something that we don't have access to in real life. So usually when we do research, all we have is our sample data. So that's why we want to know the standard deviation of the sample. Some of the problems that we learn in this textbook and in the course, though, will discuss the standard deviation of the population, and so you need to understand the symbol that describes it. And the symbol looks like an O with a little line on the top, and that's actually a Greek letter. It's the small letter sigma, and that symbol is always standard deviation of a population. For us, when we do the standard deviation of the sample, we look for S or SX. On the Texas Instruments calculator, the symbol for the population standard deviation is sigma x. However, we will never use this particular calculation for our course. Here's the formula to calculate the standard deviation of a population. And so the standard deviation is equal to the square root, and then inside on the numerator we are calculating the sum of each value minus the mean squared, and then we're dividing it by the total number in the population. So you have to do this like for each separate number that's in your data. You have to take that number and subtract the mean from it, and then you have to get all of those answers and add them up, and you're actually squaring those as well. So it's kind of an involved process, but that's something that you can use a formula to do, but this is not a formula that you'll be using for the homework or for the test. Variation describes the amount that values vary among themselves, and a lot of textbooks use different terminology. Some textbooks call this dispersion, some say spread. All of this is referring to variance from the mean. So variance is a calculation that you'll need to know how to do for the homework and the test, and it's a very simple thing to do. You have to get the standard deviation first. So on the previous slide, 2 slides back, where we looked at the calculator steps for getting the standard deviation, what you want to do is enter in your data, press stat var, and then arrow over to the SX or standard deviation number. Then what you do to find the variance is you square that number that you see for the standard deviation. So it's not a separate formula, it's just the square of the standard deviation. Now, variation squares units as well, so it's very difficult to describe it and to understand it. And so that's why we focus in statistics on the standard deviation. You'll see when you get into the point where you can read different research journals that were done and look at studies, you'll see them mentioning the standard deviation over and over again, and you don't really see mention of variation. So to find the standard deviation, we're going to practice this with one example. We're going to go back to the bank wait time examples, and we're going to use the calculator to find the standard deviation of the 3 different bank wait times of 1 minute, 3 minutes, and 14 minutes to see how much does it vary from the mean. So our data is just 3 numbers, and the numbers are 1, 3, and 14. So on the right, you see the steps to follow. So we want to make sure that our calculator is in stat mode first. We want to clear the data. So the first step says to press second data, arrow over to clear data, and press enter. Now you're back at the home screen. If you're not in stat mode already, then you set it up by pressing second data, and you arrow over to 1 bar stats, press enter. Now your calculator should go back to the home screen, and it will say stat. Now we're ready to type in the numbers 1, 3, and 14. So press data. It says X1, so type 1. Press the down arrow key. Now the frequency of the number, it only repeats 1 time, so you can just skip that step and just press the down arrow until you get to X2. At X2, type 3. Press the down arrow and scroll past frequency until it says X3. At X3, type the number 14. Now that we've entered in all of the numbers, press stat var. Stat var comes up with all the calculations that the calculator did. The first calculation is it tells you n. N is the total in your sample, which is 3. Scroll past that by typing the right arrow button several times until you can get to the SX symbol, and the number that you see under SX is the standard deviation of the sample. So for this example, the standard deviation of the sample is 7 minutes. In the preceding example, we used the customer waiting times of 1 minute, 3 minutes, and 14 minutes to find the standard deviation. And we got the answer from the calculator is 7 minutes. So what you'll be asked to do next is to find the variance of that sample using your calculator. And so we've already found that the standard deviation is 7, and variance is just squaring the standard deviation. So 7 squared is 49, and so the correct way to answer this is it's 49 minutes squared. Now in future examples, if you know you're going to have to find the variance, then what you want to do is when you have pulled up the standard deviation on your calculator, don't round it off or anything like that or type in the number again. What you do is just leave that number on your screen and then hit the X squared button, which is on the left-hand side of your calculator. This will automatically square the number correctly, and that is the variance. One thing that your textbook discusses is something called the range rule of thumb, and this helps us understand standard deviation without using complicated formulas or without entering the data in the calculator. This just gives us an estimate of the standard deviation, so it's a ballpark figure. If you know the range, then you can estimate the standard deviation by taking the range and dividing it by 4. Now, one thing to remember is that in many data sets, 95% of the sample values lie within 2 standard deviations of the mean. So when we want to estimate what the highest value in the data set is, if you know the standard deviation, then the high value is approximately equal to the mean plus 2 standard deviations. And the low value would be estimated by the mean minus 2 standard deviations. So basically, if you can imagine an x-axis and you have 0 in the middle, and if you go to the right 2 marks and then to the left 2 marks, 95% of your data is going to fit between -2 and +2 on the number line. Anything that is greater than 2 or smaller than -2 is unusual. And so we consider values unusual if they are not within 2 standard deviations of the mean. Now for this example, there's a link that you can click on the slide to watch a demonstration, and I've also put this link on the lesson 3.3. When you pull that up on the class, you'll see that I've pulled out these separate video tutorials so that it's easier for you to access and that you don't have to watch the whole PowerPoint to see those videos. But in this example, we're told that past results from the National Health Survey suggest that the pulse rates in beats per minute of people have a mean of 76.0 and a standard deviation of 12.5. We want to use the range rule of thumb to find the minimum and maximum usual pulse rates that might be the result of some disorder, and then determine if somebody has a pulse rate of 110, is that an unusual number? So let's go ahead and use the range rule of thumb next to find those minimum and maximum usual values. And so remember, it's all about 2 standard deviations from the mean. So the minimum usual value is equal to the mean minus 2 standard deviations. So the mean is 76, and we subtract 2 times 12.5, which they told us in the problem was the standard deviation. And so that gives us the number 51. So the lowest usual beats per minute of an individual should be 51 beats per minute. The maximum usual value is equal to the mean plus 2 standard deviations. So we do 76 plus 2 times 12.5, and we get 101. So we would expect that 101 is still usual, but that's the highest usual beats per minute value. Now we can easily answer the question if 110 beats per minute is unusual or not. And so what we would do, since we've already found the minimum and maximum usual values, since 110 is higher than the maximum usual value, we would say that it would be an unusual. So the next step is to look at what's called the empirical rule. On page 106 in your book, you'll see a bell-shaped distribution graph, and this is something that you need to have for your test. So page 106, and I've got it here on this slide, you'll want to have that either copied or printed or have this PowerPoint in front of you, because there's going to be some questions that refer to it on your test. The empirical rule says that if you have a normal shaped, bell-shaped distribution for data, then 68% of all the values will fall within 1 standard deviation of the mean. And then you can see that in this second chart that is shaded in blue, you can see that they cut up the 68% into about 34 and 34. And then 95% of all values fall within 2 standard deviations of the mean. And then 3 standard deviations of the mean is going to contain 99.7% of all values. So again, on page 106 in your book, that is the one that's got it pictured most accurately for you, and that's one that you'll want to use for the test. So here's an example where we want to use the empirical rule to answer some questions about IQ scores of individuals. And we know for a fact that IQ scores have a bell-shaped distribution, and the mean is not 0, the mean is 100, and the standard deviation is 15. So you can see on my graph up above that I put 100 in the middle for the mean, and then when I went out to the right, each mark, I'm adding 15 to it. So 1 standard deviation is 115, 2 standard deviations is 130, 3 standard deviations is 145. And as I go to the left of 100, I just subtract 15 with each mark. So what percent of adults have a score higher than 130? Well, what you want to do first is get your graph labeled correctly, like I did with the 100, the 115, and 130. And then you can see that past 130, if you're lining it up with the empirical rule, since that is 130 is 2 standard deviations from the mean, then beyond that is always going to be 2.5% of the data. So no matter what the problem is, if they're asking you for anything higher than 2 standard deviations, it's going to be equal to 2.5%. What scores are in the middle 95%? Well, the middle 95% is always located between 2 standard deviations. So that means if I go to the left 2 spaces from 100, I hit 70. And then if I go to the right 2 spaces, I hit 130. And so that between 70 and 130 is going to contain the middle 95%. You can also watch a link up above which has a video tutorial for how to get this example, and it's probably a little bit better because I'm able to write on the screen, whereas I can't do that in the. For this last example, we're going to find the range and variance and standard deviation for the given sample data. So the numbers in the data are 3, 24, 30, 47, 43, 7, 47, 13, 44, and 39. And so the range is easy to do. You just take the highest number, subtract the lowest number from it. So it's just max minus min, and you get 44. The standard deviation is something that you'll need to type in the calculator to do. So in the calculator, remember you press your data button after you have cleared your data, and you'll enter in for x1, 3, arrow down to x2 and type 24, arrow down to x3 and type 30, arrow down to x4 and type 47, and continue that pattern. Once you've entered in all the data, you press stat var. And at stat var, you can see the list of calculations that the calculator has completed. And so you want to arrow to the right until you're under SX, and you should get that the standard deviation is 17.02. Anytime you get a different answer on your calculator than what you see given in the back of the book or on the PowerPoint examples, a very common error is that you left a number out or you typed it incorrectly. And so what you want to do is go back and press the data button, and you can scroll down and check all of the numbers in your list and make sure that they're correct. The final calculation we want to do is variance. Variance is the square of the standard deviation. So what I would do is I would leave the standard deviation number on my screen. I don't type it in again, and I just press the x squared button to square the answer. And so I get approximately 289.57 for the variance.